The most powerful telescope in the universe, the NASA James Webb Space Telescope, hasn't passed up the chance to surprise us in a few weeks since it began operating in space. The James Webb Telescope discovered the oldest galaxy a few days ago, and the brand new NASA telescope is now occupied with studying the planets in our solar system. The most recent James Webb Telescope image is a captivating image of Jupiter that has now been made public by NASA. The enormous telescope is positioned to look at some of the earliest galaxies and stars ever created as it orbits the Sun at a distance of about 1 million miles. Since it takes that long for this ancient light to reach us, or more specifically, reach the $10 billion Webb telescope, viewing these objects is equivalent to gazing back through time by billions of years. The images, which include pictures of Jupiter, as well as pictures and spectra of several asteroids, were taken to test the telescope's instruments before the start of science operations. Join us in our video today as we explore the breathtaking images of Jupiter taken by the James Webb Telescope by peering through the peeping eye of the most sophisticated telescope in the world. As always, don't forget to like, comment, and subscribe for more exciting videos. The James Webb Space Telescope, NASA's newest flagship instrument that may allow us to look back into the origins of the universe and may aid in the search for extraterrestrial life, took the new images. It was primarily designed for infrared astronomy. As the largest optical telescope in space, its greatly improved infrared resolution and sensitivity enable it to observe objects that are too early, distant, or faint for the legendary Hubble Space Telescope, which when launched into low Earth orbit in 1990 captured unrivaled stellar views for more than 3 decades. It is however being replaced by the Webb telescope, which will be able to look through previously inaccessible clouds of dense cosmic dust because it has a gold-tinted mirror that is over 2.5 times larger than Hubble's. NASA previously made available a small number of early pictures of Jupiter taken on July 14th by the telescope. These images were captured by engineers during earlier tests of the observatory's instruments. The Webb has proved that it can see unprecedented detail in the images, even on super bright and moving objects close to Earth, while also picking up fainter objects. This success is due to the telescope's guidance sensors, which allow Webb to precisely point, hold, and track. Astrophiles and astronomers alike will enjoy the finely detailed images of well-known features of the largest planet in our solar system that Webb's infrared camera has captured. This image, taken with the NIRCam instrument's short wavelength filter, also shows the Great Red Spot, which is the solar system's largest anticyclonic storm, large enough to swallow the Earth. It is caused by a persistent high-pressure region in Jupiter's atmosphere. Because of how Webb's infrared image was processed, the iconic spot appears white in this image. Brian Holler, a space telescope scientist at the Science Institute in Baltimore who assisted in the planning of these observations, explained that when combined with the deep field images released, the Jupiter images show the full range of what Webb can observe, from the faintest, most distant observable galaxies to planets in our own cosmic neighborhood that can be seen with the naked eye from your actual backyard. Seated at the left in the image is Europa, a moon with a possible ocean beneath its thick icy crust, and the target of NASA's upcoming Europa Clipper mission. The shadow of Europa can also be seen to the left of the Great Red Spot. The original images of Europa were captured by the Galileo spacecraft in the 1990s as it orbited Jupiter and its moons. NASA officials used modern imaging techniques to improve on an enhanced color view of Europa created by the agency in 2001. But the Webb telescope is a game changer in terms of visuals produced in such a short period of time. These images also show the moon's Thebe and Medes. Scientists were particularly excited to see these images because they demonstrate Webb's ability to observe satellites and rings near bright solar system objects like Jupiter, Saturn, and Mars. Stephanie Millam, Webb's deputy project scientist for planetary science based at NASA's Goddard Space Flight Center in Greenbelt, Maryland, was overjoyed with the findings, stating that everything was unbelievably clear and bright. She also mentioned the excitement she felt at the prospect of being able to observe these types of objects in our solar system. Webb may be able to see the signatures of plumes depositing material on Europa's surface, which Millam considers to be one of the coolest things to do with this telescope in the solar system. Webb will be used by scientists to investigate the tantalizing question of whether we can see plumes of material spewing out of moons such as Europa and Saturn's moon Enceladus. Furthermore, Webb was able to capture some of Jupiter's rings, which are particularly noticeable in the image from the NIRCam long wavelength filter. Although the Jupiter images in the narrowband filters were intended to provide nice images of the entire planet's disk, the abundance of additional information about very faint objects like Medes, Thebe, the main ring, hazes, and so on in those images with roughly 1-minute exposures was absolutely a very pleasant surprise, according to observatory scientist and NIRCam commissioning lead at the Space Telescope Science Institute, John Stansberry. The images of Jupiter and Europa traveling across the telescope's field of view were actually captured by Webb over the course of 3 different observations. This test showed that the observatory could locate and follow guide stars within the proximity of bright Jupiter. But just how quickly, though, can something move and still be tracked by Webb? For researchers into asteroids and comets, this was a crucial query. During commissioning, Webb began the moving target tracking speed limit tests using the asteroid 6481 Tenzing, which is situated in the asteroid belt between Mars and Jupiter. With a top speed of 30 milliarcseconds per second, Mars was the benchmark against which Webb was built to track objects. The Webb team observed a variety of asteroids during commissioning, all of which were small enough to be seen as dots. The team demonstrated that even for objects moving at speeds up to 67 milliarcseconds per second, which is more than twice the baseline and is comparable to photographing a turtle crawling from a mile away, the James Webb Telescope will still be able to obtain useful data. That sums up our video for today. If you enjoyed this video, watch also the next video on your screen, which presents the Dogon tribe and their mysterious connection to Sirius star system. As always, give the video a like and subscribe to our channel for more exciting future videos.